We are talking about polynomials or polynomial functions. So, first thing first is we need to know what a polynomial is. A polynomial is basically a function that is raised to a power. So, just like we write functions as f of x, we also write polynomials in the same way, but you can also see we've written p of x, okay? F of x, h of x. So, when you have got any function where a polynomial where the power is power 2, the highest power is 2, that's quadratic. So normally for this one we'll start from power 3, power 4 and such. Okay, let's say we have got 2x squared and then plus, say we have got x, let's say 4x, and then plus, let's say 8. This is our polynomial function here. So what should we understand at the end of doing this topic? We need to know how to factorize polynomials. Apart from factorizing, you need to know how to deal with remainders and factors. So we'll talk about the remainder and factor theorem, and then also the synthetic method of factorization, okay, and the long division, and equations and inequations to deal with polynomials. If you do this, then you know polynomials, and that's done. So let's start with the basic. So for a polynomial that you have been given on top here, we should know how to factorize it. And the easiest way of factorizing a polynomial is you use the synthetic method. So how do you carry out the synthetic method? What you do is you need first to understand something that we call as, let me first talk about the remainder theorem. It will be easy to connect with factorization. So the remainder theorem tells us that, let's say this is your function here, and you want to divide it by another function. Let's say you want to divide it by x minus 1. Okay, you want to take this one into this one, just like you want to take 4 into, let's say, 8. So how do you do that? If this factor that you have been given is linear, please take note. I've said linear, not, it shouldn't have any power, it shouldn't have any root. It's linear. So it's going to be easy in that way. Just get this same factor, you equate it to 0. You are going to find that your x is equal to 1. So remainder, when you have been given x minus a, so you want to get x minus a and take it into a function to see the remainder. I have said just get this x minus a, you equate it to what? To 0. You are going to find that x is equal to positive a. So how do you find the remainder of a factor? This is known as the remainder theorem. Remainder is actually going to be equal to the same function that you've been given p, but where there is x, you put a, and a coming from the factor that you are taking into your function. So for this function that we have here, if you want to find the remainder, when you divide it by x minus 1, what will be the remainder? So we'll say remainder is equal to, we'll get the function, but where there is x, we'll put 1. So that is going to be 1 to the power 3 plus 2 multiplied by 1 to the power 2 plus 4 multiplied by 1 and then plus 8. So this remainder is going to be 1 to the power 3 is 1. This is going to be 2 plus 4 plus 8. And this is going to give us 1 plus 2 plus 4 plus 8. 1 plus 2, this is a 3, a 7. So that is going to give us a 15. So this is going to be our remainder. This is how you find the remainder of a function. Now, when you are using the remainder theorem, the only thing that you can determine when you divide something into another thing is only the remainder. Now look at this. If I say 8 divided by 3, we are going to get, the answer is going to be 2. there's going to be a remainder. So the way we write it is we write plus, there's going to be a remainder of 2. So these two divide by the same thing that you divided. Let me use another number because 2's are appearing twice. Let's say 8 divided by what number can I even use? Okay, let me put 9 here. And then we say divided by 4. So 4 into 9 is 2 times, but then there's going to be a remainder of 1. And then this one you write, divide it again by the thing you are using to divide. So we need to know what these terms mean here. Okay. So when you are dividing, so this is going to represent a function. Let's say you've been given a function f of x. And then you are dividing by a certain factor. Okay, by a certain factor. Let's say it's by x minus 1. So when you get a function you divide by a factor, you are going to get the answer here. This answer that you get is known as the quotient q. And then plus you are going to have a remainder on top, and then divided by the same function that you used at the beginning, remember, or the same factor that you used at the beginning, this factor divided by x minus 1. So this is a general expression that we write when you divide something into something else. You're always going to write the quotient and then the remainder over the divisor. Let's do another question. Let's say we have got a function f of x which is equal to 2x to the power 3 plus 4x squared plus 2x and then plus 1. And say we are dividing is divided by 2x. Let me not even use this, something like this. Let's say it's divided by x plus 3. And if I use 3 again, let me use some simple numbers because I'm not working with a calculator. Yes, Temwani, you have a question? Okay. So here is our function. We want to divide it by x plus 1. So the question is find the remainder. How can you find the remainder? The first thing that I'm going to use is the remainder theorem. Simply get this factor, you equate it to 0. So if you get x plus 1, you equate it to 0, you're going to find that x is equal to negative 1. And remainder is given by, you get the function, but where there is x, you are going to put the same negative 1. That will be to the power 3 plus 4 multiplied by negative 1 to the power 2 plus 2 multiplied by negative 1 and then plus 1. And this is going to give us a negative 2 because negative 1 to the power 3 is negative 1. Then positive 4, negative 2 plus 1. So this negative 2 and negative 2 to give us negative 4 to cancel with the 4. So the answer will just be a 1. So for this question, the remainder is a 1. Now, as you can see, when you are using the remainder theorem, you can only find the remainder. How about if they ask you to find the quotient? Like if you take this guy into this one, how many times can it go there? That's what we mean by quotient. So the only way you can find the quotient is using long division. So long division, write like this. Write the divisor in here, and then what you are dividing into should be inside the root. But make sure that the powers are decreasing. So let's say if we had 2x to the power 3 plus x plus 1. This one you can see we don't have any power 2. So you write it as 2x power 3. Just make sure that the powers are increasing. So just put 0 x power 2 and then I'll write plus x plus 1. Please always make sure that you write it in this way. But this one you can see the powers you have got power 3, power 2, power 1 and power 0. So just write it the same way. It is 2x to the power 3 plus 4x squared plus 2x plus 1. Now when you are performing long division, you only use the first thing or the highest the number that has got the highest power of x. So here we're going to get x. And we'll be taking x into this. So we will say x into 2x to the power 3. So just say 2x power 3. Remember long division from, is it grade 1 or grade 2? So x into x power 3. So you can see 1x will cancel with x down here. So we'll remain with 2x power 2. That is what will remain with. And then this 2x power 2 that will remain with, will again multiply with everything that we can see, the x plus 1 here. So 2x to the power 2 times x, that is going to be 2x power 3. Make sure that if you get a power 3, write it down the power 3 here. They should be in the same order. And then 2x power 2 times 1, that is going to be also 2x power 2. This one that you get, now subtract. Since the way they have written it, subtract. So 2x power 3 minus 2x power 3, that will be 0. 4x squared minus 2x squared. The answer is going to be 2x squared. Okay, like that. What is going to be the next thing that we are going to do here? The next thing that you do is, take again this x into 2x squared. So 1x will cancel. So the answer is going to be only 2x. And again, get this 2x, you multiply with x plus 1. So that will be 2x times x, that is going to be 2x squared. 2x times 1, that is going to be 2x. So what we have here, you can see we have got 2x here, but on top we don't have anything with x. So you drop this one which has got x. The 2x, you drop it like that. And then what are we supposed to do here? Supposed to subtract. 2x squared minus 2x squared is a 0. 2x squared minus 2x minus 2x is also a 0. So there's nothing that we are getting here. Okay. So we are only getting zeros down here. So what are we supposed to do? There is still a number at the end here. We're supposed to bring this number down if you are getting only zeros. Now you can see you can only take x into something that has got x. You can't take x into 1. Like 1 over x. You can't do that. That's an improper fraction. So meaning that this question ends here. The last number that you are going to have down here is called the remainder. And then the number that you have on top here is known as the quotient. So how can you write this? So you can actually write it now in the standard form that we use. You can see it's the same remainder that we found when you use the remainder theorem. So we can say therefore that if you get 2 x to the power 3 plus 4x power 2 plus 2x plus 1, you divide it by x plus 1. What is the answer that you are going to get? The quotient, this one here. So the quotient is going to be 2x squared plus 2x. And then you always add plus the remainder. The remainder is a 1. Always divide the remainder by the same thing you are using to divide the divisor, that is x plus 1. So this is the complete answer. Sometimes they can just ask you to find the quotient, or they can just ask you to find the remainder. If they've just asked you to find the remainder, and then for your question, you you've been given a factor like this one, which is linear, it is way easy to do it. But it's going to be a bit hard, or a bit different if the divisor is not linear. If the divisor is not linear, you can't use the previous method we've talked about where you equate to 0. So let's see how you can go about it. So the question is going to be, we want to find the remainder, the quotient for the question that we are going to have here. So find the quotient and the remainder. Okay. So let's say for the function that we have been given, let's say we are given p of x, and p of x, let's say is equal to, let's say it's 4x to the power 3 plus, let's say 2x, and then plus, okay, plus, let's say a 3. And they say that this one is divided by x squared plus 1. What will be the quotient and the remainder? Now for this one, you can't equate it to 0. go to find the value of x and then you start substituting it to find the remainder. Never do that. You only equate it to 0 to use it when the divisor they've given you is linear. So how can you find the remainder here? And also, how can you find the remainder and the quotient? The only thing you can use here is long division. That's all. There's no other method unless you discover one. So write x squared plus 1. Okay, like that. Now remember what I said. We said that write it in a decreasing order. You can see from power 3 we have got only 2, isn't it? So we're going to write as 4x to the power 3. I'll just put a 0x power 2 so that I just maintain the powers to be decreasing, and then plus 2x and then plus 3. It is necessary that you do this. Now when you are using the long division, you only get the highest power of x here. That's the one you'll be using. Don't get everything. So we're only using x power 2. So say x power 2 into 4x power 3. So many people get confused here. What you are doing is 4x power 3 divided by x power 2. You can see 2x's will cancel with 2x's on top. So we'll just remain with 4x. So x power 2 into 4x power 3, the answer is going to be 4x. And then this 4x that we get now multiply with the x squared plus 1. So that is going 4x times x, that is going to be 4x to the power 3. And then 4x times 1, that is just going to be 4x. So just write it here. Please make sure that you write terms down the corresponding what? The corresponding power of x. This is power x, this is only x, this is also x. So here just put 0x power 2. Okay, and also at the end here also just put a 0 because you just want all the terms to be there. And then now subtract. 4x to the power 3 minus 4x power 3 is 0. 0x power 2 minus 0x power 2 is 0. 2x minus 4x, that is going to be negative 2x. And then 3 minus 0 is a 3. So this is what I'm going to get. Now we can't take 4x x squared into negative 2x. Why? You can only take something into if the power is the same or higher, not if the power is lower. So meaning that for this question will end here. What we have found here is the remainder. And then what is on top here is the quotient. Therefore, 4x to the power 3 plus 2x plus 3, if you divide it by x squared plus 1, the answer is going to be 4x. That's the quotient. And then the remainder is going to be 3 minus 2x. Don't get confused because I've started with 3. Always divide by the divisor, which is x squared plus 1. So this is how you write this. Okay, this is how you write it. Now, this was the remainder theorem. You can actually determine the remainder like that. For a factor, for a function, if you have got a function and then there is a certain term after you divide, you find the remainder is 0. Such, let's say for example, we say 4 into 9, it will give you a remainder of 1. The answer is 2, there is a remainder of 1. So meaning that 4 is not a factor. But 4 into 8 is going to give you 2. What's the remainder? Is 0. There is no remainder. So meaning that 4 is a factor. So when you get a function, you divide it by a certain divisor. Let's say by x minus 1 or any divisor. Find that the remainder is giving you is 0. Just know that this, which is in the denominator, is a factor of what is on top, and that is how you factorize. Okay, and that is known as the factor theorem. So the factor theorem states that for any divisor that is a factor of the numerator, the remainder is going to be a 0. Okay, let's make sense from what we're talking about. Let's say for example, we have got we've been given a function f of x, which is equal to say x to the power 3 plus, let's say, 2x, and then say plus x and then plus 2, like that. Okay, so for this function that we have here, we want to find out if it if there is any if it can be divided by anything. Or let's say if we divide it by x plus 1, is x plus 1 a factor for this function or not? In other words, divide x plus 1 into this function, you find out the remainder. Now, since this is linear, just equate it to 0, okay? Just equate it to 0. And we are going to find that x is equal to -1. So come here. So remainder is equal to, where there is x, put -1. -1 to the power 3 plus 2 times -1 plus -1 plus 2. So remainder is going to be equal to -1 to the power 3. That is going to be -1 minus 2 minus 1 plus 2. It should be like this, okay? So here, I should have changed something here. Okay. This was supposed to be a power 2, forgive me. This is supposed to be a power 2, so this is supposed to be a positive 2. All right. So we can see if we have got a factor like this. So it's power 3, power 2, and then x, and then a constant. So this one is going to give us a positive number. Okay, like that. So what will be the remainder here? So this is going to be 2 plus 2. That is going to give us a 4. You can see it does not cancel. So meaning this cannot divide. We are not going to get a 0. Let me change something here so that you see now how it is going to work if we change it like this. Let's say I made this as a negative and then I made this as a positive. So where I've substituted here, this is supposed to be a negative, right? This is supposed to be a negative. This is supposed to now be a positive. Okay, because this was positive. So this -2 cancel with the positive 2. This positive 1 will cancel with the -1. The remainder is 0. So what does this mean? It means that x plus 1 is a factor of this function. So what does that mean again? Let's find out the quotient. That should be the next thing. Uh, when you just see that the factor you are using to divide is giving you a remainder of 0, just know that that thing can go exactly into what you are dividing into. Okay, it is a factor. That's what you mean by a factor. But then what will be the quotient? So to find the quotient, you can use two methods. You can use the long division method, or you can use the synthetic method. Let's use both of them. Let's start with the long division because we've been talking about it. So we are using x plus 1, and then here we're going to have x to the power 3 minus 2x to the power 2 plus x plus 2. Remember, we only use the highest power of x, so we're using x here. X into x to the power 3 is going to give us x power 2, and then multiply x power 2 times x power 3. X power 2 times 1, that is going to be x power 2. Okay, and then simply put a 0x here so that you just balance, and also put a 0 here, just balance the terms, and then now subtract. X power 3 minus x power 3 is 0. Negative 2x power 2 minus x power 2. This is going to give us negative 3x power 2. X minus 0x. That is going to just give us x. And then 2 minus 0 is going to give us 2. And then again, get the same x here. You come and divide into the highest power down here, negative 3x squared. We are going to get only negative 3x. This negative 3x multiply with the x. That is going to give you negative 3x squared. And then same negative 3x multiplied by 1. That is going to give you negative 3x. Just put a 0 here so that you balance all the terms. And then again, subtract. Negative 3x squared minus negative 3x squared, that's a 0. X minus negative 3x, that is a positive 4x. 2 minus 0 is a positive 2. And then again get x. Take it into 4x. The answer is going to be a 4. And then get this power 4. You multiply with x. That is going to be 4x. Get the same 4 multiplied by 1. That is going to be what? That is going to be a 4. Okay, like that. And then here again we subtract 4x minus 0 is 0. 2 minus 4, this is giving us a negative 2. But then for this one, there should be something that has just changed drastically. It was supposed to give us x minus negative 3x. Okay, hope I've not missed anything. Let's just go through it again together so that we find the correct thing. When we get, remember we got this thing, we equated it to 0, isn't it? It gave us negative 1. We got the negative 1 and put where there is x. So if we put it here to be negative 1, and then if we put it here, it will give us negative 2, negative 1, positive 2. Okay, so the answer was actually no. So this wasn't a factor, because from here you can see this will cancel. The remainder is supposed to be a negative 2, and that's the same thing we are finding down here. The remainder is a negative 2. So I wasn't wrong. I just missed when I was doing the first one. So I should have just changed a certain sign for the function that I had initially. So I was supposed to have a negative here. So if I use the negative here, meaning that this term would have been positive, and it means that this function that I have would have been a factor. So let's put a negative here so that it shows it becomes a factor. So negative x minus 0x, this is going to give us what? This is going to be negative. And then if we subtract here, negative x minus negative 3x, that is going to give us a 2. Okay, a 2x. And then if we say now x into 2x, this was supposed to be a positive 2 here. And then 2 times that, this was supposed to be a 2, this was supposed to be a 2. So the remainder now at the bottom is a 0. So when you just find the remainder being 0, so it should confirm, the answer we should find at the end here should be a 0. Just know that the remainder is 0. Now, it might have confused someone. Please, if you are behind, be free to ask. Be free to ask. So, what does this mean? It means that if the function which is on top, x to the power 3 minus 2x squared minus x plus 2, if you divide it by what? What were we using to divide? It was x plus 1. It is going to give you what? What's on top here? X squared plus minus 3x plus 2. So can you, there's no remainder. It's supposed to says plus remainder over the quotient, but there's no remainder. 0 over anything, the answer is 0. Can you notice that we can also get what is in the denominator here? We multiply with this. Can you notice that? So meaning that x to the power 3 minus 2x minus x plus 2 is the same as x plus 1 multiplied by x squared minus 3x and then plus 2. This is how you factorize functions. So we have factorized this function. It has given us this, and we can further factorize this quadratic which is here. So this is method 1. You can use long division, but we could have used the synthetic method. The synthetic method is actually way easier. How do you use the synthetic method? Simply, remember we are saying we are dividing this function here by x plus 1. And what did I say? I said equate this one to 0. Going to find that x is equal to negative 1. So for the synthetic method, what you do is write it like this. You've seen the way I've written it. Now get the numbers in front of the function that you want to divide into. The highest power of x, the number there is, the number in front of x to the power 3 is a 1. And then for the next one, 2. Please always make sure that the power is decreasing. If there's no power 2, just put a 0 there. So the next coefficient is negative 2, the next coefficient is negative 1, and then you have got a constant which is a 2. So what do you do now to use the synthetic method? Just put a 0 down here and then add 1 plus 0, you get a 1. This one that you get, multiply with a negative 1 on top, that will give you a negative 1. Again add negative 2 plus negative 1, that will give you a negative 3. This negative 3 again multiply with the negative 1, that will give you positive 3. Negative 1 plus 3 is a positive 2. This same 2 multiply with the negative 1, that will give you negative 2. The end here should give you a 0 because the last thing that you do is giving you the remainder. So 2 plus negative 2 is 0. If it doesn't give you 0, just know that that thing you're dealing with is not a factor. So meaning that, remember the highest power here was what? Power 3. So the things that we get after performing this function, these ones which we get down, be adding now x. But since the highest power here was power 3, so drop by 1. So this should be power 2. And this should just be x. And this should be a constant. So this means that this is another factor. X squared minus 3x plus 2. You can see this factor is the same factor which we found here. So you can find the quotient using the synthetic method. Very easy. Okay, we've talked enough. Let's go through exam questions. I've talked about everything you need to know about polynomials. Let's apply now the knowledge to exam questions. Given that f of x is equal to x to the power 3 plus kx squared minus 2x plus 1 gives a remainder k when divided by x minus k. Find all possible values of what? Of k. So what are we applying? We are applying the remainder theorem. Remember we said that we are dividing by x minus k. So if you are divided by x minus k, this is what? This is a linear function. So equate it to 0. Going to find that x is equal to what? K. And we said that put remainder is equal to f of what? Of a. That's what we said. A being what you get after you equate the function to 0. Okay, but here we've been told that it gives a remainder what? A remainder k. So where there is r, put k. And this should be equal to f of a. In the function where there is x, you are going to put what? K. So that is going to be k. It was x power 3, so it becomes k to the power 3. And then plus k. Where there is x, we put again k to the power 2. And then minus 2. Where there is x, we put k plus 1. So this gives us k is equal to k to the power 3 plus k to the power 3 minus 2k plus 1. I'm going to take this k the other side, so remain in 0 this side. And this is going to be 2k to the power 3. If we take k this side, it will become negative. So it will become negative k minus 2k. That will be negative 3k. And then plus 1. So I can as well write this as 2k to the power 3 minus 3k plus 1 is equal to 0. Are we okay up to here? Is there anyone who is behind? Be free to ask. These things will come in your test 1, they'll come in your exam. Okay? So when you do this, your aim is to find the value of k. Basically, what you are doing is how do you solve a polynomial function? You need to find the factors. And how do you find the factors? The easiest to use is a trial and error method. Trial and error method. So just start with numbers 1, 2, and 3. Normally, between 1 and 2, 3, 4, they should give you the answer. You get a positive or a negative. Only these small numbers. Okay, it's very easy. So let's start with positive 1. So let's say when x is equal to 1, you want to find out if I remember we said that if x is equal to 1 is a factor, when we get 1, we put where there is x, it should give us 0. If it gives us 0, then x minus 1 is a factor. Okay, that's what we said. So let's start with 1. Let's put where there is x. So if we put where there is, where there is k with 1, so it will become 2 times 1 to the power 3 minus 3 times 1 plus 1. This is giving us a 2 minus 3 plus 1. This is giving us 0. So can you tell me, when we used k being equal to 1, so is k equal to 1 a factor or not? Mobita, is k equal to 1 a factor or not? Or you are all lost? It is a factor. Okay, very good. It is a factor. Why? Because when we substituted 1 in the function, it has given us 0. Okay? So remember what I said when something is a factor. It means it was this one was this side. Remember? So meaning that this was actually supposed to be k minus 1. But then we need to find another factor that we should be able to multiply with k minus 1 for us to be able to get this. How do you find the other factor? You can now use the synthetic method. Let's use the synthetic method. This is how you solve these equations. So using the synthetic method, very easy. Just get your k is equal to 1, and then remember, write this comma thing like this. Start writing the coefficients of k, starting with the highest power. The highest power, the number in front of k is 2. What is the next number that we're going to write? Okay, so you write 0 first. Anyone who knows why I've written 0? Yes, yes. So you need to make sure that the powers are decreasing. So we don't have anything with power 2, so put 0 there. And then I'll go to power 1, that's a negative 3. And then I'll write a constant, which is a 1. And then now, just write a 0 down here. 2 plus 0 is 2. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. Negative 3 minus plus 2 is a negative 3 plus 2 is a negative 1. Negative 1 times 1 is a negative 1. The remainder should always give you a 0. So remember I said now just put x with a power 2 here and then you put a x. So meaning that the other factor, apart from, sorry, I'm talking about x because we are used to x. This is supposed to be k. Remember we're dealing with k. So the other factor that you're supposed to write is 2k squared plus 2k minus 1 is equal to 0. Okay, this is another factor. I just wrote this 2k squared, 2k, and then negative 1. And then equate it to 0. So if you multiply this, it will give you the same thing that is on top there. And then now let's see what we are going to get. We're supposed to factorize again the 2k squared plus 2k minus 1. That's a quadratic. So for that one, like, you're supposed to look for the product, the sum. The product is negative 2. The sum is 2. Are there two numbers that you can multiply, you get negative 2? If you add them, you get a 2. Do you know of any two numbers? So there is no. Okay, so simply equate this one to 0. We're going to find that x minus 1 is equal to 0 to give you x is equal to 1. And also equate this one to 0. We're going to find that 2k squared plus 2k minus 1 is equal to 0. Since this is quadratic and we can factorize it, use the quadratic formula. K is equal to negative b. B is 2 plus or minus square root of b squared. B is 2 squared minus 4ac. A is 2. C is negative 1 over 2a. And this is going to be negative 2 plus or minus 2 squared is a 4. Negative 4 times 2 is 8 times negative 1 is positive 8. 8 plus 4, that is a 12. Now I want you to know that square root of 12 is the same as square root of 4 times a 3, and the square root of 4 is a 2. So square root of 12 is the same as 2 square root of 4, 3. So I'm going to write 2 square root of 2 and then divided by 2, 2. So I can as well write this as a, I'll factorize out a 2 and then we remain with negative 1 plus or minus, we'll have a root 3. And then down we have got 2, 2. So this 2 can cancel with this 2. So the answer is negative 1. I'll first get a plus root 3 over 2, or negative 1, I'll get a minus root 3 over 2. So these are the three answers, this one, and this one. These are the possible values. Find all the possible values of k. That's how you find it. Let's look at this one. Very easy questions, as you can see. When the polynomial p of x is equal to x to the power 3 plus kx squared, minus 2x plus 1 is divided by x minus 4. The remainder is k. Is it not the same question? Find all the values. Okay, this was the same question. Is there anything different? This is the same question, huh? This is coming from two different past papers, but you can see it's the same question. Exactly. X power 3 kx squared negative 2x plus 1. You can see two different past papers, the same question. This is how they do. They will just repeat questions. All right, let's look at this one. Let x minus 2 be a factor. And okay, let x minus 2 be a factor of this guy. Find a relationship between a and b. Guys, this is very easy. Okay? The first thing is you need to understand just the word factor. If you hear the word factor, what do you know about the remainder? Anyone? Mutali, if you hear the word factor, what should you think about for the remainder? Okay, the remainder is 0. That's the thing. And remember we have said that from the remainder theorem, remainder is equal to polynomial of a. So just get the x minus 2, you equate it to 0, go and find that x is equal to 2. So where there's remainder, we put 0. And that is going to be equal to, now we write our function, but where there is x, we put 2. So 2 power 3 minus 2 power 2 plus a times 2 plus b. So it's going to be 2 to the power 3 is 8, 2 to the power 2 is 4, plus 2a plus b. And this is going to give us 4 plus 2a plus b. The question is find the relationship. This is the relationship, or just make a subject the b subject the formula. So say b is equal to take the 4 and the 2a the other side, so that will be negative 4 minus 2a. This is the relationship. That's the relationship. As direct as that. And then the next one is given that the remainder when f of x is divided by x minus 3 is 10. Find the values of a and b. Don't remove this relationship down because it's going to be used to find the values. But we just want to write another equation so that we have two equations and then be able to solve. They have said that when we divide the same function by x minus 3, the remainder is 10. So again, we'll say remainder is polynomial of x. But where there is remainder, we are putting 10. And that is equal to the function. Is x minus 3. If we equate to 0, we're going to find that it's x is equal to 3. So we'll say 3 to the power 3 minus 3 to the power 2 plus a multiplied by 3 plus b. And this gives us 10 is equal to 27 minus 9 plus 3a plus b. And this is what? 27 minus 9 is that 18. And then 18, if we take it the other side, it will find 10. So 10 minus 18, that will be negative 8. And then I'll take the 3a the other side, negative 3a. And that is going to be equal to b. This is another equation. So since b is equal to this and b is equal to this, we can equate the two equations. So say negative 8 minus 3a is actually equal to negative 4 minus 2b. I'll take 8 this side, I'll take the 2b this side. So the 2b will become positive 2b minus 3a, and that will be equal to negative 4. The a to become positive. So this is going to be negative b is equal to negative 4. Positive 4. Negative 4 plus 8 is positive 4. Divide both sides by negative. So b is equal to negative 4. And then to find the value of a, use any one of the equations. Actually, what we are calculating here, was it even b or a? So this was supposed to be a, okay, from here. This is supposed to be a, this is supposed to be a, this is supposed to be a. Sorry for that. So to find the value of b is going to, we can use any one of the two equations. Negative 4 minus 2, but where there is a, we'll put negative 4. This is going to give us negative 4 plus 8, and b is giving us a what? A positive 4. So meaning this function is actually equal to x power 3 minus x power 2. Where there is a, we are putting negative 4, x. Where there is b, we are putting positive 4. This is the function. And then the next one is saying factorize. But for this one they've given here, it is way easy. You don't even need to struggle by using the synthetic method. I hope you, no, you can't see. So let me first use the synthetic method, the one I've taught you, and then I'll show you an easy way for just a type like this one. The synthetic is also way easy, and I advise you to use it. In case you can't see, you need to have mathematical eyes to see what I'm saying. So hence factorize completely, not just factorizing but completely. Remember, x minus 2 is a factor, so that gave us x is equal to what? 2. Okay, we'll do this. All right, now the coefficients. Can you tell me the coefficients that I'm going to write? The function is on top here. What coefficients am I going to write? Uh-huh. Negative 1. It's here. The function is here. Negative 4. And then positive 4. Okay, good. And then simply put a 0 here. So 1 plus 0 is 1, times 2 is 2. Negative 1 plus 2 is a 1, times 2 is 2. Negative 4 plus 2 is a negative 2, times 2 is a negative 4. The last one is always the remainder. You can see the remainder is 0. That confirms that's a factor. So just put x power 2 here. Here just put x. So what does that mean? It means that this guy here, if you factorize it, the first factor you have is the same, x minus 2. The second one will be this one we found, but don't write ones in front. So just write x power 2 and then plus x, then minus 2. So I want to factorize completely. So let's find the product of what we have here. Product is negative 2. The sum is a 1. So 1 factors. Two numbers that we can multiply to get negative 2. If we add them, we get a 1. What two numbers are those? If you multiply, you get negative 2. If you add them, you get a 1. So 2 times negative 1, it will give you negative 2. 2 minus 1 will give you a 1. So meaning that this is going to be x minus 2. For this one here, you can see we have got positive 2. So we're going to have x positive 2. Then I've got negative 1, x negative 1. So this is, we are factorized completely. Just so that you see the way they are going to ask you some other different questions. Let me use this same one so that I don't end up creating another different question. Let's say they had said that this is the same factor. After you have found, let's say there was part 4, and then they said that hence solve the inequality f of x is greater than or equal to 0. If they said and hence solve the equation f of x is equal to 0, just equate this to 0, equate this to 0, equate this to 0. It will be easy like that. But if it was the inequality, so what are you going to do? Get f of x. What is f of x? It is x minus 2, and then you have got x plus 2, then you have got x minus 1. They should be greater than or equal to 0. And then this is what you want to solve. I like inequalities. And you can't have a test or an exam at UNZA where they don't give that. So what do you do for inequalities? The easiest you do, just get this one equate to, as long as there's 0 at the end, as long as there's a 0, equate this to 0, go and find that x is equal to 0. Equate this to 0, go and find that x is equal to negative 2. Equate this to 0, go and find that x is equal to positive 1. Now we have found equal, equal, equal. This is an inequality. We don't want to find equal. So what do you do? Get the factors that you found after equating to 0. Write them on a number line. The smallest of these values you found is a -2. Write it here. The next one is a -1. Write it there. Is it a -1? It's a +1. And then the biggest is a +2. Now write the factors that you equated to 0 to find these numbers. The first one was x minus 2. The second one was x plus 2. The third one was x minus 1. Okay, these are three. So when we equated x minus 2 to 0, we found +2. So +2 is going to be a point of transition of signs. If you get any number above 2, you put in x minus 2. For example, a 3, 3 minus 2 to give you positive. When you just cross 2, it will give you negative. When we equated x plus 2 to 0, we found -2. So for that factor, -2 be a point of transition of signs. Get any number above -2. For example, a 7. 7 plus 2 is positive. So as long as you're above 2, -2 for that factor, it's going to be negative, positive. When you just cross -2 to become negative, for example, you can try get a -5. -5 plus 2 is negative. When we equated x minus 1 to 0, we found a +1. So 1 is going to be a transition of signs for this one. So get a number above +1. For example, 2. 2 minus 1 is positive. When you just cross 1, the signs become negative. Now, remember these factors, these are three factors, they are multiplying. So what you are interested in is the product of the signs. Not anything else, the product of the signs. So let's go to the signs and see their product. Negative, negative, negative. So here we're finding the product. Negative, negative, negative is negative. Negative, positive, negative is positive. Positive, negative, positive is negative. And then positive, positive, positive is positive. Now look, we want where it is greater than or equal to 0. Greater than means positive. Positive. And remember, it's greater than or equal to. So our solution set is going to be between here, and also from here, going in this direction. And normally this question you find the 7 marks and those marks. So therefore, the solution set is going to be, you can see it's closed because it was greater than or equal to. From -2 to 1. Union from 2 to infinity. This is going to be the answer. So if the question was less than, the answers you get where is negative here, going in this direction, and also between here and here. That's how you answer this. Okay, so this was from last year's exam. Is it exam or test one? The polynomial 3x to the power 3 plus is divisible by x minus 1. Find the values of p and q. So since they've said that it is divisible by x minus 1, it means that the remainder is equal to what? If we say it's divisible, it means it's a factor. What is going to be the remainder? It's 0. So just equate this factor x minus 1 to 0. We want to find that x is equal to 1. So remainder is equal to polynomial of a. So remainder is going to be 0. And then we substitute where there is x with 1. That will be 3, 1 to the power 3, minus 2, 1 to the power 2, plus p times 1 minus q. 0 is equal to 3 minus 2 plus p minus q. I'll take q the other side, becomes positive q. That will be equal to 3 minus 2 is a 1, and then plus p. This is equation 1. For the second one, we've been told that it leaves a remainder of 10 when divided by x plus 1. So if we equate x plus 1 to 0, we're going to find that it's -1. So where there's remainder, we're going to have 10. But this is when we are using where there is x, we put -1 to the power 3 minus 2 -1 to the power 2 plus p -1 minus q. So this is 10 is equal to -1 power 3 is -1 times 3 is -3, and then -2, and then negative p, then negative q. So this is going to be a negative 5. If you take it the other side, it becomes positive 5. So it will be 15. And then if I take also the q the other side, or the p the other side, it becomes positive p. And that is going to be equal to negative q. But let me swap them. I'll take q the other side, and then the 15 and the p, I'll take them the other side. So q therefore is going to be equal to negative 15 and negative p. This is equation 2. So q is equal to, and here q is equal, so equate now. So q is negative 15 minus p. The other here, q is equal to 1 plus p. Take p the other side, take 1 the other side, so it becomes negative 15 minus 1 is equal to p plus p. This is negative 16 is equal to 2p, and p is going to be equal to negative 8. To find q, you can use any one of the equations. Let's use this one on top. So q is equal to negative 15 minus, where there is p, we put negative 8. So this is negative 15 plus 8, and that is going to give us what? Is it a negative 7? Okay, so that is what that is going to be the value for p and for q. For this one, you can try. We've done this, isn't it? The polynomial p of x is equal to that is exactly divisible by x minus 2. And on division by x plus 1 leaves a remainder of negative 12. It's the same as the previous one that we've done. You want to find the value of a and b. After find the values of a and b, you now want to what? To solve when f of x is equal to 0. Simply, after you solve, factorize using the synthetic method and then equate to 0. Okay? And then for this one, given that x to the power 3 minus 4x minus 3x plus 10 is equal to this, plus that, find the values of p, q, and c. This one is very easy. It's way direct. X to the power 3, this is just a comparison. You're just comparing. You don't want to use a hard method. Just compare coefficients. So multiply x by x. That is going to be x squared. Multiply x by 2. That is going to be 2x. Negative 1 times x to be negative x. Negative 1 times 2, that will be negative 2. Then you have got x minus c plus px plus q. And then this is going to give us x squared, 2x minus x, that is going to be x minus 2, then x minus c, then px plus q. And then again distribute x squared times x, that is going to be x to the power 3. X squared times negative, so that will be negative c x squared. X times x, that is going to be x squared. X times negative 2, that will be negative cx. Negative 2 times x, negative 2x. Negative 2 times negative c, positive 2c, then plus px plus q. And then now put like terms together. Those which have got a power 2, arrange them together. So this would be x to the power 3. So these two have got a power 2. So factorize out the x. So if you factorize out x, here we're going to have a negative c remaining, here we're going to have a positive 1 remaining. So we're going to have a positive 1 and a negative c. And then we'll put x squared at the end. And then this one has got x, it has got x, it has got x. Factorize out x. Here you're going to have a negative c remaining, here a negative 2 remaining, here a positive p. So I'll start with a positive p, and then I'll write negative c, and then negative 2. Remember, I've factorized out x. And then those constants, we don't have any x. We have got 2c and q. So say 2c plus q. They should be equal to x power 3 minus 4x power 2 minus 3x plus 10. Just compare coefficients. This should be equal to this, yes. Compare coefficients. The number in front of x squared, that's negative 4, should be equal to the number in front of x squared, that is 1 minus c. So this will give you, let's take c the other side and 4 the other side. So c is going to be equal to 5. And then go to the numbers in front of only x. Here it's negative 3. How about the other side, the number in front of x? It's p minus c minus 2. But you know what c is? It's a 5 minus 2. So this is a negative 7. If you take it the other side, it becomes positive 7. 7 minus 3 is 4, so meaning that p is going to be equal to 4. Okay, and then compare the constants. 10 should be equal to the constant, which is 2c plus q. You already know what c is. C is what? Is a 5 plus q. This is 10. This is 10. If they go to the same side, q is going to be equal to 0. So this is it. That's how you solve this one. Let x minus 2 be a factor of x, and here is f of x. Find the equation, an equation that satisfied by the constant a and b. That equation is, just say, remainder. Since this one is a factor, meaning that the remainder is 0, remainder is a polynomial of a. So remainder is 0, and then get a function where there is x, put positive 2, because when you get x minus 2 to 0, find that x equal to positive 2, and then solve it. You are going to have a and b in it. And then they've said, given further that f of x is divided by x minus 3, the remainder is 10. Use that again, the other statement. And then now you also find another equation here. On the first one, you've also found another equation. Solve these two equations simultaneously. You are going to answer part 3. When you answer part 3, now factorize, because you would have found the value of a and b. And then come and equate it to 0. You find this one. As easy as that. You've answered all this. For this one, you can answer this question here. Solve. How do you solve? Simply factorize. How do you factorize? Use the synthetic method. First, start by the trial and error. You want to find what will give you a remainder. Try to use 1. Where there is x, put a 1. So put a 1 here, put a 1 here, put a 1 here. If 1 fails, go to negative 1. But if you say x is equal to 1, you are going to have 2 minus 3 plus 2. This will not work. Okay, go to negative 1. If you go to negative 1, you're going to have negative 2 minus 3 plus 3. Negative 1 will work. So x is equal to negative 1 is a factor. What does that mean? It means that x plus 1 is a factor, because you take the negative 1 on the other side. And then find the other factors by using the synthetic method. And how do you do that? You simply write this comma thing. Actually, when you use this comma method, you are also going to confirm if x is equal to negative 1 is really a factor. So get 2, get negative 3, get negative 3, get 2. Put 0 here. 2 plus 0 is 2. 2 times negative 1 is negative 2. This is going to be negative 5, positive 5. If you multiply negative 5 times negative 1, this is going to be a positive 2. Positive 2 times negative 2 is negative 2. You can see the remainder you have confirmed is 0. So just put x squared here, put x here. Meaning that if you factorize this guy, the first factor is this one, x plus 1. The next one is this one, 2x squared minus 5x plus 2 is equal to 0. Factorize this one again. How do you factorize it? What is the product here? The product is a 4 if you multiply 2 and 2. And then the sum is a 5. So what two numbers can you multiply? You get 4. If you add them, you get a 5. Anyone? So what two numbers? If you multiply them, you get 4. If you add them, you get a negative 5. So I've got negative 1 and negative 4. So we're going to say 2x squared, negative x, negative 4x, and then plus 2 is equal to 0. Okay. And then this is going to be x plus 1. We'll factorize out x for the first two. We'll remain with 2x minus 1. And then we'll factorize out a 2 for the next two. Actually, a negative 2. And then we'll remain with a positive 2x. Here to remain in negative 1 because we factorize out a negative. And then marry out those which are outside. So the x and the negative 2. So x minus 2. Then what is inside here is 2x minus 1. Just equate now each term to 0. Equate this one to 0. You find that x equal to -1. This one to 0, x is equal to 2. This one to 0, find that x is equal to half. These are your answers. This is not an inequality, it's an equation. If it was an inequality, that's why now you draw that table that I drew earlier. You find the signs and then you go to the appropriate sign. So this is it for this class. This is polynomials. More likely your test 1 is going to end on this topic, but they might include other topics.